Today we will continue our lesson with the chapter 1 with the subtopic of week 2, which is infinite limits and limits at infinity. So the limits at infinity means if a function of fx is 1 where fx approach to positive infinity or fx approach to negative infinity. Okay, this function we approach to positive or negative infinity because when that x approach to a, which the x approach to a positive and x approach to a negative exists. So where a is a finite number. So the limit of infinity is a function where x is approach to infinity or negative infinity. So what is the difference between infinite and infinity? Limits of infinite here, this is limit of infinity. Okay, the difference here is the first one as approach to any number, any variable, but the second one is as approach to infinity and negative infinity. So in order to compute the limits, there are several laws that you have to know, which is the first law is the summation law, sum law. If you have a limit of two function and they have addition between that two function, then you can separate for both function. Means you calculate for limit of fx first when x approach to a, and then plus with the limit of gx when x approach to a. But if you have a minus here, so you can separate limit of fx when x approach to a minus with the limit of gx when x approach to a. But if you have a limit of cfx where c is a constant, so you can put c in front and then you multiply with the limit of fx as approach to a. When you have a multiplication or product of two functions like fx and gx in limit, and you can separate both like this, which is limit of fx when x approach to a. Solve for this one first and then multiply with the limit of gx when x approach to a. And then the last law is the quotient rule. Quotient law, which is the limit, and you have two functions here, but you need to limit for both, and you can do it separately, which is the limit of fx when x approach to a over limit of gx when x approach to a. But you need to remember gx must not equal to 0 because the denominator cannot be 0. So in order to evaluate this limit, we can use two methods, whether use direct substitution or factorization of the numerator and denominator. Okay, later we can look one by one how to solve this limit by using the law. So computing the limit and behavior, we need to find what happened to a function as it goes to positive or negative infinity. Infinite limits. Okay, so infinite limit, let's say you have a function of limit fx when x approach to a is equal to infinity, and limit fx when x approach to a is equal to negative infinity. So if the function fx when x approach to negative infinity for all x approach when x approach to a, from left and from right hand side with the actual letting x approach to a. So the case 1, let's say you have a reciprocal function which is fx equal to 1 over x squared. So the graph for the reciprocal function will be like this. Okay, 1 up to the positive infinity, but not touch at 0 from the left, and it's also same but come from positive infinity at x and move upwards until see positive infinity at y here. So when x approach to 0 from the left hand side, the value of fx is unbounded in the positive direction, which is limit 1 over x squared when x approach to 0 negative must be equal to positive infinity. Why it happened? Because if we look at this graph, when x approach to 0 from left hand side, it will move upwards, and we didn't know this function will end at which point. So we conclude that this function will have the positive infinity. So if you have the value of 1 over 0, actually is not 0, it's not MAT error, but it will give you positive infinity based on this graph. Okay, so this is the 0 negative. So what happened to the x approach to 0 positive? Okay, so if we look at this graph above, and we look at the graph from 0 positive, this means 0 and 0 positive is at your right hand side, 0 negative is at your left hand side. So from your right hand side means this graph also move upwards until positive infinity. So the limit of 1 over x squared when x approach to 0 positive also give the same value, which is positive infinity. Therefore, the limit of 1 over x squared when x approach to 0 exists since both value when x approach to 0 negative and x approach to 0 positive is same, which is positive infinity. So the value for limit of 1 over x squared when x approach to 0 also equal to positive infinity. So now, case 2, we look at the function of fx equal to 1 over x. Okay, so if we draw this function, it's become like this. Okay, so the first one is the limit of 1 over x when x approach to 0 positive. And the bottom is the limit of 1 over x when x approach to negative infinity and 0 negative. Okay, so if you look at here, when x approach to 0 from left hand side. So from left hand side, the value of fx move to the negative infinity here. Okay, move upwards until see negative infinity. So limit 1 over x when x approach to 0. Okay, this one approach to 0 means approach to the value of 0 here. So move downward until see negative infinity. So the answer is negative infinity. But we try find for 1 over x when x approach to 0 positive. So at this line, at the center, so this graph move upwards until see positive infinity. So the answer for limit of 1 over x when x approach to 0 positive is equal to positive infinity. Means these two functions, which is limit of 1 over x when x approach to 0 negative, is not equal to limit of fx when x approach to 0 positive. Therefore, we conclude that limit of 1 over x when x approach to 0 does not exist. Okay, so now we look at the limit at infinity. So if you have a function and the function x approach to positive infinity or negative infinity, so how to solve this function? Let me look at other example. So this graph consider the graph of 1 over x like previously. So when fx is equal to x approach to negative infinity, means your x approach to negative infinity here, and it will give the value of 1. And if your fx approach to positive infinity at above right hand side, this one left hand side, so this one will give positive infinity equal to 1 also. So the limit of fx as approach to positive and negative infinity will give the same value, which is 1. Limit fx when x approach to plus minus infinity is as to 1 same. So limit of infinity of rational function. So if we look at example 3 here, that we have a function of limit of 3x plus 4 over x minus 1 when x approach to infinity. So in order to solve this question, we need to divide the numerator. Okay, first you need to look at the numerator variable, which is the variable give us the highest degree of variable. So the first one is x power of 1, and this one is constant 4, so it doesn't have a variable. So we take the value of x here, because the x here with the lowest of power, x power of 1. So every single number here, numerator and denominator, need to divide by x. So the first one we divide 3x with x, and the second one we divide 4 over x also, and at the bottom or denominator we divide by x also, x over x minus 1 over x. And then we simplify this, then we get 3 at the top, 4 over x, and the bottom is 1 minus 1 over x. But now we want to find for limit of x approach to infinity. So remember, any number approach to infinity and then 0 at the bottom, so this number will give us 0 because of limit approach to infinity. So we substitute the value of 4 over x is equal to 0 here, and 1 over x also is equal to 0. So 3 divided by 1, then we solve, we will get the value of 3 here. Okay, so this is the reason why we take any number divided by infinity is equal to 0. So based on our calculation here, when we divide by the largest number, so it appear to 0. The number will give us more to 0. Okay, so because infinity is too large, we didn't know the exact value of infinity. Let's say 1 million, 1,000, and so on. So we divide any number, divide by 1,000, let's say. Then we have a 0.00000 uncertain 0. So that we conclude that 1 over infinity or 4 over infinity is equal to 1, is equal to 0. Okay, look at example 14. So if we have a limit of rational function, but both denominator and numerator have a degree of power here. So first, when we substitute the value of negative infinity at the above function, of course we cannot solve like that, because when we multiply, we will get infinity over infinity. So infinity over infinity, we cannot solve or left the answer like that. So what we need to do is we find the highest denominator power, divide by the highest degree of denominator. So we look at the denominator here. Okay, 3x cubed plus 3x. Then all single number here need to divide by x cubed. So when we simplify this, x squared divided by x cubed means 4 over x at the back minus 5 over x cubed, and then over at the bottom 3 plus 1 over x cubed and 7 minus x cubed. So what is the answer? When we substitute all the value, we know any number divided by infinity or negative infinity will give us the 0 value. So when we solve, we will get 0 over 3. So 0 over 3 is equal to 0. And then example 15. Okay, example 15, we have a function of limit x cubed plus 2 over x squared, 6x squared plus minus 5 when x approaches to infinity. So, like previous example, we find the highest degree power of denominator, which is x squared here. So, every single number need to divide by x squared. So, x cubed over x squared, 2 over x squared, 6x squared over x squared, and minus 5 over x squared. And then we get like this. And we substitute the number of infinity into the number. Then we will get infinity over 6. So infinity over 6 is equal to 6. Why we have infinity? Because the greatest number, or divide only the smallest number, then it will also give us the smallest number like this. Sorry, the greatest number. Okay, then limits involving radical function. So what is the radical function? Radical function is a function, it have positive and negative function. So this is the example, which is the limit of x over square root of 9x plus 4 minus 2 when x approach to 0. Okay, when we substitute x is equal to 0, then we will get 0 over 0 here. So means when you get 0 over 0, you cannot solve like that. So what we need to do, we need to multiply by its conjugate. So what is a conjugate? So when you have a number, you get 0 over 0, and it have a number like this, you have a reciprocal function, and you need to multiply by conjugate. So what is a conjugate? Conjugate is any number that have a quadratic function like this, and here we need to multiply by the same number exactly, but we change the symbol from minus to plus here. And then after we multiply by its conjugate, then we multiply all the number if we can. Then we multiply, we will get x square root of 9x plus 4 plus 2 over 9x. Okay, then we solve by substitute the value of x with 0. Then at the end, we will get the value is 4 over 9. For example 17. So we have to eliminate the function of square root of 1t plus 2 minus 3t minus 2 over 2 minus t when t approach to 2. So first of all, we substitute the function with t equal to 2 first. And then we get 0 over 0. So we cannot left our function like this. So what we need to do is we need to multiply by its conjugate for both up and down, numerator and denominator. So after we multiply by the conjugate, we expand one by one. So the first one multiply by the second one. Then we can get like this. So after we expand, and we expand another times, and we solve for the equation for numerator first. So denominator, you don't change anything yet. So after we solve the first equation at numerator, then we will get negative 2t plus 4. Okay, now we want to rearrange our calculation in order to cancel numerator and denominator. So we rearrange at the above, then we will get 2 times 2t over 2t times with square root of t plus 2 plus 3t minus 2. Okay, so we cancel this one, and what left is 2 over square root of t plus 2 plus square root of 3t minus 2. But now our function of limit have the value of t is equal to 2. So at the end, we substitute back the value of t is equal to 2 here. Then we get the answer at the final is equal to 1 over 2. Okay, So please don't do a mistake. When you multiply a square root, please write down back the square root if you cannot simplify like that. Okay, so if you can simplify, then you can simplify. Okay, this is the basically students do. They did not put the bracket. So if you did not put the bracket, it will become wrong. Okay, next example, 18. So if we have a 1 over 9 plus x minus 1 over 3 over 3. 1 over 3 over x. So this one also we get 0 over 0. Or negative 1 over 3 over 0. Okay, so this is what we need to do first. We multiply by its conjugate. Okay, 9 square root of 9 over x over square root of 9 over x. So if we want to make all number here 3, so we need to multiply by 3 for the denominator and numerator. Why we multiply by 3? Because at our function at the top, at the right hand side is 3. Okay, then we expand at the denominator. We just multiply because we have the same value of denominator here. So we will get 3 minus square root of 9 plus x over square root of 3 plus square root of 9 plus x. And then we multiply by 1 over x here. Okay, so 1 over x is at your denominator. So put it in front of 3x at the bottom denominator. So when we simplify this one, we can multiply 1 by 1. Then we simplify at the denominator. We will solve and we will get the answer is negative x. Okay, negative x over 3x multiply with 9 plus x. Okay, multiply with 3 plus 9, square root of 9 plus x. And we substitute the value of x is equal to 0 into a given function. We solve and then we will get 1 over 54. And then example 19 is also same but a little bit different now because we have a square root and not square root inside the question together. Okay, so what we need to do first, as usual, we find the highest degree power of denominator, so which is 9x here. So every single number divide by x. Okay, because of the number at numerator have square root here, so the number that we have weight also need to do it in terms of square root. So how to put into a square root? Because the number at denominator is x, then divide by x multiply by x. Because if we cancel like this, we will get x also. Okay, so over x squared here, we just substitute into the function of square root here. Then we simplify 1 by 1. We get x squared over x squared plus 3 over x squared. And at the bottom, we didn't change anything, which is 1 over x minus 2x over x. Then we solve, we will get 1 plus 3 over x squared over 1 over 4 minus 2. Okay, this one actually minus. Okay, then we get the final answer is equal to negative 1 over 2. Okay, then example 20. So example 20, we can do like our example 19. Okay, we find the highest degree of denominator first, which is x here. So all denominator and numerator need to divide by x. And then next step, we need to divide the denominator with square root of x squared in order to substitute the value into our function, which is square root of x squared plus 3 here. And after that, we simplify this. Okay, simplify, we get 1 plus 3 plus 3 plus 3x. And we solve it, we substitute the value of x with infinity. So any number divided by infinity is equal to 0. And we will get square root of 1 over negative 2. Negative 1 over negative 2, so we get 1 over 2. Okay, next. Okay, next, if we have both numerator and denominator in terms of reciprocal or quadratic square root. Okay, so what we need to do is the first one, we need to find the highest power of degree variable at denominator. So we found here, which is x squared. So every single number in the bracket need to divide by x squared. Okay, then after we divide by x squared, we simplify like this. So what left is 1 over x plus 3 over x plus 5 over 1 over x squared plus 8. And then we substitute with x approach to infinity. So we substitute with infinity here. So we substitute, we solve, and we will get cube root of 5 over 2. Okay, so next, this is the example or tutorial for chapter 1 with 2. So the S you can try by your own.